All right, in part two, we're going to start looking at something that we call periodic trends that are on the periodic table. If you'll notice, I flipped my periodic table over. That's why there were two of them in the file that I posted online. On this back side, we're going to color in our metals, our metalloids, and our nonmetals only. So I'm going to outline it so that you can see it, and then you're going to want to pause it so that you can color it correctly. And there's a little space on the bottom where you can put your answer key for your colors. So, metals. And there are a lot of them. They are by far the biggest block of elements on the periodic table. All of those, as well as your lanthanides, and your actinides. Big chunk of our periodic table is taken up by metals. Our metalloids, remember, touch that imaginary staircase. Now on this periodic table, you don't see it, but the line goes like so. There are our metalloids. And that leaves everything else that is not colored in, so I'm going to color in blue, as nonmetals. And like I said, when you get a chance, you should probably put a key on the bottom. I put my key on the bottom. Looks like that. Metals, metalloids, nonmetals. So that way you have it. This periodic table is going to be very useful to you on your next exam. So the last thing we want to talk about too are what we call periodic trends. And you've got 4 boxes here, and each one of them is so that you can draw in arrows with a trend. So the first one we're going to talk about is atomic radius. You're going to see words magically pop in. It's because I have to do this upside down. So I'm pausing my video in between to make sure I can write correctly. So the trend with an atomic radius. Arrows are going to indicate for us increasing either in size or whatever trend we're talking about. Atomic radius all has to do with size. So when you go down the periodic table, down a family, the atomic radius increases, and when you go to the left, the atomic radius increases. So let's talk about what this thing atomic radius is. The atomic radius is the size of an individual atom of an element. It increases as you go down a family because there are more energy levels and electrons being added, so the atom is growing bigger on the outside. And it decreases as you move left to right across the periodic table because there are more protons. Those protons can pull on the electrons stronger, so it actually pulls those electrons closer together. So you increase as you go down, you decrease as you go left to right. The next trend we're going to talk about is ionization energy. Ionization energy is how hard it is to take a valence electron from an atom. It's how much energy you got to put in there to remove an electron from an atom. And the trend for this, ionization energy increases as you go up a family, and it increases as you go left. So here's ionization energy. How hard it is to take a valence electron from an element to form an anion. As you go down a group, it gets easier to take electrons, so ionization energy decreases as you go down a group because there are more electrons there, so they're more willing to give one up. And as you go across a period from left to right, it increases because you're getting that much closer to the magic number of 8 in chemistry. 8 electrons is great. We want 8 electrons. The next trend we're going to look at is how reactive elements are. So this is how stable or abundant an element is in nature. As we go up a family, reactivity increases. And for this one, it would help if I put the arrow on the right spot. Reactivity increases. And for this one, reactivity increases as you go away from the center. So we're going to put a double arrow on it. As you move away from the center of the periodic table, elements get more reactive. So here's how we define reactivity. Reactivity is how stable or abundant in nature an element is. It increases as you move down the family, and it increases as you move to either end of the period. All right, the last trend that we have is what we call metallic characteristic. So how metallic something is. So the metallic nature of an element, how metal-like something is. Metallic characteristics, metallic nature increases as you go down a family, and it increases as you, or decreases as you go left to right, and increases towards the right of the periodic table. And here's your metallic characteristic, or your metallic nature definition. It's how metal-like an element is. It increases down a family, and it decreases as you move left to right. Those are our periodic trends. There is one group of elements, though, that you need to realize that these trends don't apply to, and that's the noble gases. The noble gases are stable with 8 valence electrons, so they don't look the same, they don't act the same as the rest of the elements. So on that bottom where you put the key, I want you to write the following. So you're going to write periodic trends do not apply to noble gases. None of the noble gases will ever follow these periodic trends. That's it.